In modern Britain, there are a lot of systems like this. A pathetically small amount of panels put onto a nice big roof, and it makes no sense. So today we are ripping out these 5 piddly solar panels from about 10 years ago and installing a much bigger, more powerful system. But the question is it worth upgrading an old PV system for a new, more powerful one? Well, make sure you like and subscribe and stay to the end of the video to find out. Could anyone have got a bigger ladder? Welcome to rainy Britain, where everyone loves to do solar at the wrong time of the year. So we've got the whole team here today, and the reason for that is one, Tom planned this job from start to finish, pretty much. So this is the first time I've heard anything about it, which is quite nice. And so he's here sort of taking the lead, getting everyone going. Time is of the essence this week because the customer's going on holiday on Thursday afternoon. So we've got to get everything done in basically 3 days, maybe 3.5 days at a push. But the weather is my biggest worry on this one because it is forecast to chuck it down with rain all week. But let me tell you what we're doing here. By the way, today's video is sponsored by Doncaster cables because we're installing 3 special types of cable today: PV Ultra, EV Ultra, and Powerwall Connect. And we're going to go on a little deep dive into each one of those cables and why we use them a bit later in the video. So this system was installed about 10-12 years ago under the original feed-in tariff scheme. It's part of a new build development, although it's not new anymore, it was at the time. And they used to do these kind of token solar systems where they stick a few panels on a roof and maybe they got some money back for some grants or something like that. But the reality is the system's not generating nearly enough power for our customer. The amount of money that he's getting from the feed-in is pathetic. So he's asked us to rip out these 5 panels and fill the roof with as many new high-powered panels as we can get. And on top of that, install battery storage and a new EV charger. So in today's video, we're going to just walk you through how we do it all, step by step. Hopefully it'll be a bit of an eye-opener for you, and you can let us know all of your questions in the comments because we love to try and answer your questions. Let's go. So this is the existing garage supply. It's basically a 2.5 3-core steel armoured cable. They've just spurred off of the socket in the front of the house, and then they ran it into a separate garage consumer unit, which is crazy but pretty standard for these kind of new build properties. Which then that was doing this spur, which I presume is for like a garage door or something, not sure, and then sockets and lights. So we're completely upgrading the supply to this garage. We're putting a 16mm armoured cable in, EV Ultra, which means it's got data in as well because we're going to be installing a network switch in here. We're going to be installing a Wi-Fi router in here because we're putting a Tesla wall connector on there. We've got 2 Tesla Powerwalls, one now and one in January to go on here. And the customer's already prepped a nice little base on the floor for them, which is fantastic. Garage board, EV charger, solar edge inverter for all the new panels on the house, and PV Ultra cable to come in between, but we'll show you as we go as much info on the install as we can. So this is the old inverter that Ruben's just ripped out. It's literally a tiny little Solis inverter, 1700 watts. So that was up in the loft. We've removed all electrical equipment that shouldn't be in the loft from the loft now. Ruben's got all the bits and pieces out. How was it up there? Was it a neat install?
It was neat, but it just wasn't great.
Yeah.
Like, it's weird. For the positive and negative coming out into the loft, they just put a 10 amp MCB on both of them, and that was their means of isolation. On the DC cables? Yeah. Oh wow. It's really weird. And then from there into a DC isolator. That's weird that they've done breakers on the DC. That's very rare. Let us know in the comments if you've come across that before, breakers on the DC. I mean, they're still up there because I couldn't take them out because of the panels. Because
I'm going to rip the panels off in a minute, so we'll go up and show we'll show our viewers what Ruben's talking about. So this is the main house consumer unit. Now there was a generation meter and an AC isolator here, and then the PV cable, the old one that fed the inverter, goes through the hole in the wall here and up. As you can see, we've neatened things up now. We've got rid of all that because everything's going to be going in the garage or in the Powerwall gateway. But we've just got to put a little blank in there, and then we might put a circuit in here for the Solar Edge mod bus, and maybe put the Solar Edge mod bus up above, but we'll see what we can do. Let's go up into the loft. Right, so this is the board that they put everything on. I think this has been done by one of those companies that literally just smash out tons and tons of installs. It looks like they basically prepped a board, maybe in their workshop or something, with the inverter, AC isolator, etc. on, and then they just literally come up into the loft, screw the board to the wall, connect the DC cables in. So this is what Ruben was talking about. You've got a 10 amp circuit breaker for each of the DC cables, the negative and the positive, which is very strange. I've never seen that before. So not sure why they've done that, and to be honest, really not sure whether these MCBs are designed to trip DC. So let me know in the comments. I mean, they are 60898s, B 10 amp, 6KA, they're GE breakers. It's a bit random, but yeah, let us know if you've come across this before and why you think they might have done it that way. This is the AC cable, which is the one that came up on the outside of the house, and it's literally just a 1.5 3-core steel or armoured. Now this doesn't meet regulations because the regulations for solar PV state that the AC supply for any PV system should be a minimum of 4 mil. So even though it's a tiny inverter, they should have wired this in 4 mil, not 1.5 or 2.5. And it looks like there's a bonding cable, which means they might have actually bonded the panels, which is another slightly unusual thing. And all of this is leading me to wonder whether it was a European house builder that actually put this system together, because fusing the DC side, that's very European. Bonding the array is also very European. So I'm very intrigued. So what we're going to do is we're going to get up onto the roof and start removing these panels. What we always do here at Artisan Electrics is we recycle the old panels. You may have seen a video, if not I'll leave it up here on the screen now, where we sent a whole load of old panels to Mauritania to have a second life, and that's what we'll be doing with these old panels too. Although, you know, they're fairly old and less efficient, they've still probably got 10 to 15 years of life in them, and to send them to a country that has a lot of poverty and where they need electricity to, for example, pump water up from irrigation wells to irrigate their fields to be able to grow crops, this is an ideal setup. So we've got a partnership with a company who basically takes these panels off our hands and takes them to Mauritania for us, and it just gives that feel-good factor that they're not just going to landfill, they're going for a second life to really help a lot of people. Oh, well that's nice. The original MC connectors, I think, before the MC4 came out, and they're basically a little bit of a pig to get undone, especially with muddy, greasy hands. So I think I'm going to get some gloves on, and I'm going to get a second pair of hands to help me. I love the rain. Why did I ever leave the UK? It's such a lovely place to work in. It's so refreshing. None of that horrible sweaty heat that you get in places like the south of France. Anyway, I've just had a lovely chat with a customer. I'll explain his situation a little bit later because it's quite interesting, the journey that the customer's been through, and a bit of a horror story that he had with his air conditioning. These do actually just pull apart, which is probably why they replaced them with MC4s, because MC4s need a tool to disconnect, whereas as you can see, other than me, and I know that people would say I'm a bit of a tool sometimes, you don't actually need a tool to disconnect these. And done. Perfect. And here comes Ruben to save the day. And there we have one roof with 6 panels less. So I was right, they have actually bonded the rail here. They've just basically attached it on with a lug to one of the roof hooks so that this rail is bonded, and then I guess technically the bottom rail's bonded through the edge of the panel or something. Let me know if you do this. I have talked about this in previous videos before. We don't usually do this in the UK, but I know that they do in places like France and Germany and the Netherlands. Maybe it's coming in the UK, who knows? Now you'll notice that there's quite a lot of lichen on these panels, and lichen is a kind of a bioorganism. Never sure whether it's a plant or an animal, but it sticks to stuff and grows, and it can be really difficult to remove. Fortunately, because it's wet, it's going to rub off quite easily. So what we're going to do is just clean these panels up before we put them into our stores ready to send off to our Mauritanian friends, and that way they've at least got fairly clean, good to use panels, and we're not exporting British lichen to Africa.
Okay, so I've just got the third panel now of Hardy backer board. Just one more to go. Obviously, because of the dimensions of this wall we're fitting it on, they've got to be cut down. So it's a little bit fiddly, trying to get them to fit. But yeah, just one more to go. And that's all this done, then we can start mounting the batteries.
So the customer had an old BP charger, so just ripping that out now, as well as the cable, which runs to just above where the garage board's going to be. So we're just going to rip out that cable, put in some new EV Ultra, fed via that board.
We love our customers. To all of our amazing customers, including the one from today, thank you. Look at this. Taste test from Luke.
Perfect amount of crispiness, no fat.
Oh, yes. And the best sauce on the planet. Today's video is sponsored by Houses of Parliament sauce, because the only good thing to ever have come out of the Houses of Parliament is this sauce. That sounded really political, didn't it? I'm politically neutral, just so you know. Now this is the MTB 10,000, and it's giving us all the light that we need right now. It runs off all different power tool batteries. It's really good, and obviously as we've got the power off in the garage, we need some battery powered light, and this just does the trick. It's like having your own moon to work by. It's just so bright. So there's a link in the description if you want to get a cheeky discount on all Unilite products, including this bad boy. It's a game changer, isn't it? It's so bright.
We're just going to core a hole through this little garden wall, and then basically the new submains to the garage can go along the back wall, round here, down underground across this bit of patio, and then it'll go all the way around to the meter cupboard where we'll have the Tesla gateway it'll connect into. And then also we've got a armoured PV Ultra which is going to run from the inverter in the garage, and that'll go up the side of the house to the new panels.
So this Doncaster cable's PV Ultra cable is unique in a number of ways. One of them is that it's got the writing on the outside. So in bright yellow, it's got danger, DC cable, live during daylight. Because when the sun's shining, the PV panel's generating, this DC cable will be live. Now inside, you've got multiple layers. So first of all, you've got the steel wire armoured. Now you can have tough sheath version of this as well, which is like MYYJ. Or high tough, some people call it. We would use that normally, but because it's underground, it really needs to be armoured. Then inside, underneath the armouring, you've got the bedding here, but then under that bedding, you've got like this fine powder that sort of lubricates the cable inside and allows you to strip it easier. There we go. So in here is this piece of nylon fibre, and you might wonder, well, what's that for? Well, I'll show you what it's for. So then once you've got underneath the inner bedding, you've got your positive and negative DC cores. Now this cable comes in 4-core or 2-core option. So this is 2-core 6mm. They do a 2-core 4mm, and then they do a 2-core and 4-core 6mm as well. And then these are like normal DC cables, so they are double insulated as well. So not only have you got outer sheath armouring, inner sheath, and then double insulated cores. It's very clever and innovative, and that's what we love about Doncaster cables. They make products that make electricians' lives easier. Now of course it's not cheap, but it results in a better job, which we really like, and it's why we always factor it in when it makes sense on our installs. Until this armoured PV Ultra came out, the only option really was to use normal steel or armoured cable. The issue with that is it's not rated for the kind of voltages that you get with DC. You know, you can get you can get up to 1,000 volts DC on a high voltage string. And not only that, but the inner cores are single insulated, not double insulated. So this really is the way forward now. But of course, this didn't exist like until a year ago, maybe. So it's a solution that not everyone knows about. But if your installer, really is a lifesaver now to help you to do a really safe and compliant install.
Okay, boards are finally up. The brickwork was a bit wobbly, so we've done our best to get them as flat as we can, but yeah, happy with that. So we're just going to mount the consumer unit because we've ripped the old one out. We're just actually waiting for the batteries, the Powerwalls, to arrive. They probably should be here in an hour or so. So once those are here, we'll get those mounted, well I will. And then yeah, just get the inverter on, the isolators, and then lastly feed the supply coming from the house over to here, get that into the board, and then yeah, we're pretty much done in here.
Look like I'm going out to catch some crab. So we've dug up down there where it's coming out the garden wall, under the slabs, and then basically the 16mm sub-main's going to run all the way along the side of the house under these aircon units, round here, and I've just got to drill through this garden wall because the meter box is around the other side of the house. So I'm going to have to try and get behind this gutter, but I think it will be better to drill from the other side in because I'm not going to get the drill in there. So I'll walk around, see if I can get that done now, and then hopefully the cable will turn up and we can get that in today.
So just pulling in some cables now. We've actually got 4 cables to go out from the house to the garage. From the Tesla gateway, we're running a new supply for the garage. That's this 16mm EV Ultra steel wire armoured cable. Then we're running a separate Cat 6, which is just purely for data. So the Cat cable within this is actually going to be for CT connections and comms for the Tesla Powerwall. That's Cat 6 armoured. It's going to be purely for hardwired Ethernet to the garage. And then we've got a 2-core 1.5 armoured for the 12-volt communications with the Tesla Powerwall. And on top of that, from the roof, we're going to have an armoured PV Ultra cable, which is going to do the DC cable from the house to the solar edge inverter in the garage. So it's all happening. It's going to be,
I mean,
you've got to go through the wall, up, across, and down. You're going to need at least about 5 metres inside, aren't you? Oh, is it? Okay. The most expensive cable is the one that's 2 centimetres too short. Tom, we'll have to see. We'll just see if it can make it work.
How's it going, mate? Don't know, let's ask her. How's it going? Yeah, that's what I thought.
So one of the things that is a big impact on the customer's energy use here is these air conditioning units. They've actually got 4 air conditioning systems here for basically multiple rooms throughout the house, and so that does cooling in the summer, but it also does some heating in the winter as well. And the great thing about having AC and solar is that on hot days in the summer, when the sun's shining, you're generating a lot of solar energy, you're also cooling your house, and so the two things combine to kind of counteract each other, and you can run your cooling off your solar energy. Now, the customer did say that he had this unit installed just a couple of weeks ago and there was a bit of an issue. Let me explain. So the customer was outside with bare feet, doing a bit like what I'm doing now, just touching the unit, and he got an electric shock. So he called the installers and it turns out they wired it up wrong. I don't know what they'd done. Maybe they wired the neutral and earth the wrong way around or something, but basically the casing of the AC unit was live and they had to change the wiring. And he did say that the whole thing was a bit of a cowboy operation. Like they turned up, all of their batteries were dead. So they basically drilled for like 10 minutes and then their batteries ran out and they had to sit around waiting for their batteries to charge. Just little things like that that are not very professional. And you know, tradespeople, take pride in your work, get organised, plan ahead. All of those little things make a big difference to customers, as you can see. Just talking about preparation, we have a slight problem maybe that the cables are maybe a tiny bit too short. I think Tom, when he came out and measured originally, either he did it a little bit too roughly or he was being a bit tight with his cable length calculations. I always say leave 5 meters too much. The extra labor to pull it in, find it's too short, pull it out again and pull in a new one and wait for a new cable to be delivered, it's not worth the cost of an extra 5 meters of cable.
So we're just measuring how high the bracket's got to sit for this to sit properly as low to the floor as we can, because customer might get a second one to sit in front of it in the future, so can't really raise it up too high. So we're just eyeing that up now.
I'm digging a hole, and the reason is, as standard, we fit conjudisc earthing electrodes. Now, most electricians just bang an earth rod in the ground, but as you'll see here, there's cables coming under, there's drain pipes coming under. The risk of hitting underground surfaces is so high, and also an earth rod doesn't tend to provide a very good backup earth, so conjudisc gives us a really good low resistance earth reading for the property. It is a bit more expensive, and as you can see, it's quite labour intensive. We have to dig a 600 by 600 hole. Now, I'm not taking all the praise for this. Lee did about half the hole and I'm just finishing it off for him. So we'll share the load here. And then we put some conductive concrete in the ground with the conjudisc, with an earth wire going up to the main earthing terminal in the property, and that gives a really good backup earth provision in case of a power cut or in case the main supplier cuts off the earth to the property.
So once the hole round by the meter cupboard 600mm deep, then we've got a conjudisc, and this is the one where you don't have a pre-made earth on it, so you can run this back to wherever. So if you've got a further distance down the garden or something, basically just get a drum of 16mm CPC, run that to the location, put a lug on it, and then what you do is you mix this stuff up, creates like a paste. You put that over and that will seal the joint. Leave that for 24 hours. Then when it's set, you can put it in the hole and you can fill it with concrete and backfill it with the remaining earth, and then test it, and hopefully you've got a good reading.
Okay, we've just got the Tesla Powerwall mounted. Ruben kindly came and gave me a hand. And I think Ruben said we've made sure the feet are touching the ground, because I think the customer may in the future may want another one put on. And obviously these go back to back. So now we've done that, it's just gonna be a case of positioning the other items where they need to be, like the inverter. We're gonna run some trunking down, the isolators, etc. We've already run the cable in for the charger, but the charger's not here yet. So we just run that in and cord it up the other end. So it's just, yeah, it's gonna be a case now of just positioning things so it all looks symmetrical, and yeah, just get everything on the wall basically.
So I'm about to shoot off now to the office, and tomorrow we're at Solar and Storage, and Luke has got his AM2.
Yeah, so hopefully actually when this comes out, I should have passed.
That's it, yeah. So how are you feeling about it?
Yeah, like, I mean, I'm as confident as I can be. It's, I know how to do everything sort of thing, it's just whether the pressure gets to me on the day, but yeah, hopefully I should be fine. Like I say, it's everything I know, it's just take my time getting it right, I suppose. That's
it, yeah. So for those of you who don't know what the AM2 is, it's like the ultimate exam for electricians. It's sort of the final step in the training process, and it's quite a rigorous exam, isn't it? Where you've got to, like,
split over 3 days.
Yeah.
Like the main exam, the install part's like 10 hours, I think. Well, for me, the AM2 is a little bit less, it's 8 hours, but AM2S and AM2, I think it's 10 hours. And yeah, it's split up into sections like safe isolation, testing, inspecting, fault finding, things like that. So yeah, like I say, hopefully just do it step by step. We should be right.
Yeah, it's the point where all these like last few years of experience and training that you've had all comes to a head.
But that's the thing, I think I benefit as well, because I've been actually working on the tools for 3 years. Some people just do the course and then go straight into that and do the AM2 straight away. So I've got the experience there, I've got the knowledge. It's just putting it down to not pen and paper, practical.
and you can do the work already, we know that for a fact, so it's just the whole passing the exam thing now, and sometimes it's a psychological thing.
Yeah, like as soon as you say an exam or mention the word exam or test, for me, my head just goes and I panic, but...
Yeah, man, I'm sure you'll be fine. Maybe we can do a little update on Friday.
Yeah. Sounds good.
Anyone remember these? VP Chargemaster, the most hideous and useless EV chargers that were ever made. It's just basically like a plastic box with some cheap electronics in it, and they banged loads of these on the wall back in the day. I mean, they did the job, I guess. Let me know in the comments if you've got one and it's still working. I think this was installed, well, quite a few years ago, before the smart charging regulations came in. So we're ripping this out and we're putting a Tesla wall connector in so that the Tesla Powerwall and the EV charger all talk to each other and do the things that they're supposed to do and can see the solar, etc. But yeah, this old box is coming out.
Okay, so it's just come up to 4 o'clock. As you see, we've got the board on, the cable to the EV charger and the sockets and lights that would exist in. We've got the trunking on the battery, so tomorrow it would just be a case of mounting a bit more of a trunk in, the inverter on, some isolators, just to finish off this end. And then poor old Liam Rubin, I'm not here tomorrow or the rest of the week actually, it's just Liam Rubin tomorrow. Yeah, it's just Liam Rubin tomorrow, and they've got the hard job of running the cable back. They're 16mm armoured all the way through the garden. You'll probably see the route that they've had to take, so I feel for them tomorrow. But yeah, it's the end of the day today. We're just going to tidy up and get out of here.
This has got to be the most flexible armoured cable I've ever seen. Look at that. Because it's PV Ultra, it's got the DC cables within it. They're fine stranded. It makes it really flexible, which is really nice because it's much easier to work with. And to be honest, whenever we work with armoured cables, we always find Doncaster cables in general are just much better quality and easier to work with, easier to strip, for example. Ruben's too fast for me. There we go. I mean, we can pull through more if you need it, but I don't know.
Yeah, we'll have a little measure up.
Bacon butties, you beauty. Oh, don't let my wife see this footage.
So yesterday when you guys weren't here, I put the conduit disc in, filled it with concrete, backfilled it with the mud, and got a test reading of 35 ohms. So not bad for just being put straight in the ground. It's been a day. When this all gets connected up, I'll test it again and see if it has dropped. Yeah, that went quite well. It's just a bit of a pain to dig, that's all.
So it's day 3 on this project. Yesterday we were at Solar and Storage. You may or may not have seen that video already. Today we're in the thick of it and it's all hands on deck to get this project pushed forward because we've got a bit of a tight deadline on it. So let me show you where we're at. So Ruben and I have been busy just putting in the last cables. We had some delays with the cables, but they're all here now. So Ruben's getting them clipped back to the garage. Then I'm going to start dressing them back this way. But let me show you how they've got on up on the roof. So up here they've got all the rail on the DC cables through and the solar edge optimizers in place. We've got 6 440 watt panels bifacial going on here in portrait. And then on the other roofs, we've got some interesting and slightly more complicated configurations. But you'll see this deck type flashing that we use is quite good. It enables us to bring the DC cables through really neatly through the roof and give a nice watertight seal. And it just avoids any vibration wearing away at those DC cables and wearing away at the insulation. A lot of installers might just do a little notch out of a tile and then run the DC cables under the tile. But the issue with that is that it will vibrate over time and it will wear away the DC cable. So something to look out for and just to try to avoid. If you're getting an installer, make sure they install the penetrations through the roof properly.
Okay, I can barely hear myself, so I don't know if I sound weird or loud or whatever. What we're doing is I've just pulled the cable through along with these other 2 that are going out to the garage. They're running behind these lovely bamboo and trees concoction thing going on here. So what we're going to do is we're going to lift off the top bit of gravel where the cables are running because the customer said that it's being backfilled another 4 to 6 inches. So what I'm going to do is put some banding onto the wall a bit lower, and then at least all the cables are together. They are armoured, so they can get buried.
So we're using an all-round band because there are 4 cables all together in a bunch, and to put them all side by side, not going to look neat, it's going to take up a lot of space. So we're bunching them in a nice neat bunch, but we're making sure that they're in the same order all the way through so they're not twisted around each other and things like that. So it will look really neat, and the all-round band is metal, so it provides that fireproof fixing. Not that it's really needed on the outside, but it's just good practice and we do it as standard usually anyway. So I'm going to get some holes drilled and get some clips in. So this is the other Doncaster cable that we're using. It's called EV Ultra, and as the name suggests, we usually use it for EV installations. However, in this case, we're actually using it to feed the entire garage. We're using a big chunky version of EV Ultra. In case you didn't know, they do all different sizes. So this is a 16mm 3-core EV Ultra, and it has a Cat cable within it, a data cable. I think it's Cat 5 or Cat 5e probably, and that allows us with one cable to get power and hardwired Ethernet to an outbuilding, for example, in this case the garage. But if we didn't have that, then we'd end up installing multiple different Cat cables out to the garage for CTs, RS485 cables, Tesla Powerwall communications and data. So it's just a nice, neat way to do it, and again it reduces the number of cables that you need to install, makes your job neater, makes your job faster. Inside here we have 16mm single cores, brown, blue and green yellow. So that's for our main feed to the garage. That's going to be on an 80 amp fuse. And then we've got this category 5 enhanced super screened data cable, F/UTP, so foiled on the outside and then unfoiled twisted pairs. And you got your 4 twisted pairs there within that cable. So you can use that for hardwired Ethernet, you can use that for CT connections, RS485 connections. So this is what we call our Save the Whales bag, usually used to protect porpoises from imminent death, but today we're going to use it to lift some solar panels safely up onto the roof.
Well, I'm not an expert in laying patio, but we're relaying the slabs after we've got all that lovely Doncaster cable underneath. Of course, with a bit of caution tape.
We've reached an exciting moment. The panels are going on as we speak up above my head, which is why I'm wearing the hard hat now, because there's a lot of roofing material being moved around, panels being lifted and stuff like that, and the chance of something falling off the roof is fairly high. So we've done a green flag here, which basically means anyone walking past needs to wear a hard hat at this point. And when the roofers are not up there, we take the green flag down, and that means it's a safe zone. But the good news is I've got my cable clipped up now. So before we show the panels going on, I'll show you this cable. Can you see it? It's invisible. Let me show you why. So we've hidden it behind this this trunking, basically. Now, I'll be brutally honest about this cable. There's a good and a bad to it, right? The good is it's really flexible, which means it's really easy to work with, really easy to install. The only disadvantage I would say about it is because it's so flexible, it's a little bit wobbly as it goes up, so it's a little bit harder to get it perfectly straight. But overall, I'm pretty happy with it. Now, the good thing is because it's flexible, you can work the kinks out quite easily. Now, what's the advantage of using PV Ultra versus using normal DC cables, which are like singles? Well, if you do singles, then you need to run it in conduit, right? So that includes installing conduit, clipping it to the wall, joining the lengths, then pulling the DC cables through. It's quite labor intensive and faffy. Also, you've got to label it up with like a big yellow label or something, whereas the DC cable from the PV Ultra is actually labelled on the outside of the cable. And if you want to bury DC cables, the only option really is to put them in a duct, but then they're not really protected. They could be chewed by rodents outside and things like that. Whereas with this, it's armoured, steel wire armoured. So as it goes under the ground, if anyone was to hit it with a spade or a hammer or a rodent was to have a go at it, it's protected, which is really important when you've got high DC voltages going underground. So this is the air conditioning unit that's been recently installed that I was telling you about earlier, where the customer was getting an electric shock off of it. The installers came back and rewired it. However, yesterday when we were pulling in the cables, obviously these pipes are super loose and they were nudged slightly and gas started to go everywhere. So the guys who installed this have had to come back and redo the connections and repressurize the system. But is it normal? If you're an air conditioning installer, tell me, is that normal that these pipes are completely loose with no fixings whatsoever? And the guy's literally been out, redone all of the connections and everything, but he's not like fixed anything back. Is that normal? I feel like it's really not normal. And now the thing is, I'm having to be very careful because I'm getting my cables behind, because I'm actually fixing my cables to the wall. I'm having to be careful because I don't know, hopefully he's done the connection properly on this now, because I don't believe that you should just be able to loosen a gas connection by nudging it slightly. But I'm being very careful to not loosen it again, because otherwise we're going to have the same issue. These guys do solar as well apparently, but the customer decided to go with us for his solar instead. I think it was a good move. Talking about the shoddy installers, the list seems to keep growing in the solar industry, and I know there are a lot of really good installers out there, like you know, some of them we partner with to help our customers who are not in our area, but there are literally a plethora of people getting into the solar industry right now, and one of the biggest issues we've seen is actually the energy suppliers getting into the solar industry, because what they're doing is they're actually doing installs for a loss, so they're actually losing money on them, which means they're doing them so cheap that obviously there's no way we can compete. I mean, we're premium anyway because of the quality of work, but you know, and we fit really good products, but actually, like, even for the budget installers, they can't compete with these energy suppliers. And they're then subbing these jobs out. They're getting lashed in really badly often, and the customers are getting stuck with installs that either don't work properly or are just not to a very high standard, and therefore might not stand the test of time. But because it's backed by like an energy supplier, which, you know, as an energy supplier they have a good relationship or a good reputation, customers don't necessarily know. And it's creating this price war where, like, new guys who are getting into the solar industry, independents like us, you know, smallish companies, local companies, they're having to try and lower their prices to get into the market, to be able to, you know, build up a core base of customers to grow from. And this race to the bottom is happening where people are getting undercut. The margins are getting so thin that there's not much pie to go around, and people are having to cut corners, having to do a bad job in order to actually survive. And it's resulting in a lot of people going under as well, unfortunately, at the moment. So it's a bit of a funny place, the renewables industry right now. And that's why we just focus on high-end stuff, because that's where customers value quality over price often, and those are the people that we really want to work for. We're not interested in getting part of this race to the bottom, because it's only going one way and it's not a good way. So the other innovative cable that we're using here, one of the three, is this. This is Powerwall Connect cable, and Doncaster Cables actually invented this along with Tesla. Tesla basically requested them to make this cable, and it's absolutely genius. So we use it because it contains all of the cores that you need, power and data, and there are two types of data, or two types of low voltage signal within this, to do all of the power and communications for a Tesla Powerwall 2. So if I strip this back, I'll show you. It's really cool. Are you ready for this? This is probably the most innovative cable I've ever seen. So within this you have 3 copper cores, 6mm 3-core. Now this is MYYJ. I don't think they do an armoured version of this, but it's just high tough. 6mm 3-core for the power. So that could take up to 40 amps, which is kind of what we need for the Powerwall. But then we've got 3 sets of communications in here. If I strip these little ones back, you've got this twisted pair here, brown and blue. This is for your 12 volt communications, and that ideally needs to be like this. Need to be like a 1mm twisted pair comms cable. Then the other 2 are a lot smaller. They are basically very small, fine stranded communications cores for the other signals for the Powerwall. Now the nice thing about this, again, these are shielded, so there's no interference going to happen between the cores, and you've just got a little grey core here and a little yellow core. This provides you with all of the power and communications you need to get from the gateway, the Tesla backup gateway, to the Tesla Powerwall, and usually they're a certain distance apart. It could be they're close to each other, could be that they're quite far away, but either way, this allows you to run one cable from the Tesla gateway to the Powerwall and do a really nice neat install, which will be quicker because you're only clipping one cable instead of clipping multiple cables. It really is a game changer. Now, Tom, our in-house Tesla Powerwall expert, has just told me a bit more about this because he's fitted tons of this stuff. And so he said that this is for your 12 volt and ground connection, and then you only use one of these actually for your channel plus and channel minus connections. But this shield here, you actually have to put some earth sleeving over it and earth it, because that basically protects the cable from interference if it's properly earthed. So massive thanks to Doncaster Cables for sponsoring today's video. If you want to find out more, there'll be a link below. So the solar panels are finally all up on the roof, and I'm just having a quick tidy up because there's a lot of rubbish from these kind of installs. I'm trying to separate all the rubbish and get it all sorted out into different categories so that we can recycle it properly at least.
So all the panels are on now. So we're now starting to check to make sure everything's where it needs to be. I've just come up here and had a look at what Lee and Ruben have done, and I really love this. Obviously it goes all the way through into the darkness, but if anyone's coming up here, be so careful that they don't think this is coax and stuff and just cut straight through it. So I really like this. So with the Solar Edge system, each optimizer provides 1 volt. So what we're checking here is polarity, but also checking to see that we've got 14 volts, hopefully. Providing all the optimizers are connected in, because we've got 14 panels, 14 optimizers. So fire this up, 14.1, and the polarity is the right way around. Perfect. And what I do like to do is just double check that the polarity is correct. So we've now got minus 14, 14. Perfect.
So it's in the end of the day, and the guys have left. Me and Tom are going to pull a little bit of a late one. Just going to try and get the system commissioned because the board to the garage is now live, and then tomorrow it's really final testing, buttoning things up. I'm just cutting this rail up as well, but we will see you tomorrow. So Ruben, we've got a present for you. Can you guess what it might be?
An apple? I don't know.
A big red apple. You know how every time we're filming videos, we have to try and avoid getting a shot of that little Milwaukee impact that you've got, that you absolutely love.
Yeah.
Well, Hilti noticed it in a tiny little clip, and they were like, "Why is Ruben using that? We've got something similar," and they've sent you this.
Oh snap! Straight from Hilti.
And it's a mini impact with loads of different angle options and things, like little different attachments. We can throw that Milwaukee impact in the bin once and for all.
Whoa. Throw it in my wardrobe for safekeeping. Come on, man.
That is actually really cute, isn't it? Is it light?
Fair play, yeah.
Oh, nice.
Yeah.
So the other thing that has newly arrived is the Hilti heat gun, which we've been waiting for quite a while. Lee and Ruben, when they went to Shan to the Hilti event and the Hilti factory, they got to try this out and they were really impressed with it, but it's been quite a long time coming. So I'm looking forward to trying this and putting it through its paces. I will do a Tools for Sparks video about this, so if you haven't subscribed to Tools for Sparks yet, our other tool related channel, make sure you do. Oh, nice. Just what you need on a cold day. We're just talking about maximum demand in situations like this, and it's quite tricky because you've got power flowing different ways. So for example, technically, if we've got 2 Powerwalls here, they can pull 5 kilowatts. The 7.4 kilowatt EV charger, that takes us to 17.4 kilowatts of potential load on this garage. Plus you've got lights and sockets, so maybe another kilowatt there. So you could be looking at about 18 kilowatts, which is about 75, 76 amps. But then you've got the solar inverter. Now that's a 5 kilowatt inverter, but it's never going to draw power, it's only going to generate power. And that generated power is actually cancelling out effectively some of the loads here in the garage, and then the net balance of power will flow either back to the house or be drawn along that garage cable. But then you've got to think about other scenarios. For example, if he was discharging both his Tesla Powerwalls and generating 5 kilowatts on the roof, he could be potentially pushing 15 kilowatts of power back to the house through the garage supply cable. So you've kind of got to look at all the possible scenarios of loads and generating sets and what is the worst case scenario, and then design your system accordingly. And that's what we've done here. We're going to put this whole building on an 80 amp fuse. So that's fine. At the moment, we've only got one Powerwall, so it's going to be on a 63 amp MCB. But then when we add the second Powerwall, we'll put it on an 80 amp fuse, and it'll be fine. But it's just an interesting thought process to go through. This is going to end up being a 2-part video. There's so many long talking segments in here, but I'm trying to be a bit more in-depth and educational, because some of you guys said that, you know, you missed that on the channel. So I'm trying to do that a bit more. This is the earthing system I just wanted to talk about in the garage. So this is the earth that comes in from the 16mm armoured. But actually what we've done is we've just put in a connector block and not connected it, because there is a separate earth rod for this garage already. And obviously you want to use the earth electrode for the building rather than the exported PME from the house. Especially as we've got a car charger here and we're not putting a pen fault device because we've got a TT earth. But we have installed a conduit disc at the house, so the whole house has a TT backup earth as well. So it's kind of an interesting one because we've got 2 earth electrodes essentially at this property, and we're just going to use the local one. We got about 22 ohms on the reading on this one, so that's good. Earthing is always a bit confusing. So when you're doing armoured, obviously you still need to earth the outer sheath of the armoured cable if it's being buried. So what we've done is we've earthed it at this end, but at the other end we've actually separated it, and it's just in a plastic compression gland at the other end. So that means that, again, we're not like exporting that PME through the armouring and the metal casing, but the cable has the earthing protection that it needs. So a couple of things I like about this: when you trigger it on, it stays on. So you can leave it standing there and, you know, heat stuff up with it. And then you've got different speed settings and heat settings. So you've got the fastest speed, it blows the air quite fast, but it's a little bit less hot. And the second is like medium hot. Third is like super hot. And it flashes and then it goes solid when it gets up to temperature. So that is like really, really hot now. I can barely hold my hand in front of it. And now it's gone solid. It's saying we're at the right temperature basically. So really cool. And then to turn it off, you just click it and it turns off. But it's got this safety thing where it actually blows cold air through it for a little while to cool itself down as well. So very, very clever. So I'm just going to start going through the certificate. Lee's on it and he's already laid it all out and filled out all the like locations of the distribution boards and the kind of structure, and we've just got to go through now and just do some testing. Obviously the garage was existing, the lights and sockets, but because we're connecting them to a new consumer unit, we're changing the fundamentals of the circuit. We do have to test everything just to make sure it's all okay, and we're going to be testing our garage supply, our new circuits, anything that we've either altered or added to basically. So we just livened up our hardwired Ethernet connection to our inverter. My mum will be really annoyed with me now because I'm speaking with a mouthful. I've got to stop, turn the camera off. Our customer is so lovely. He's left us this welcome note and it's got all of the information that we might need about the local facilities, the Wi-Fi code, etc. And it's just really, really sweet. I thought I'd share it with you. So we're just putting the finishing touches on everything and having a tidy up, but the sun's just come out from behind the clouds and our client is generating 3.5 kilowatts, most of which is going in to charge the battery right now because they're only using about 0.5 kilowatt in the house. So it's fantastic. And the advantage of this system is it's got 3 different orientations: east, west and the biggest part on the south, which means that he's going to get a long day of generation as the sun transits from east to west throughout the day, with the morning sun on the east panels and the afternoon evening sun on the west panels. And it's for that reason that we've chosen solar edge system, because in a normal string inverter setup, if you didn't have sun on one aspect, it would bring down the whole array. In this case, we'll be generating the maximum amount of PV in every possible scenario. And if there's any shading, the panels will still be protected and output the best that they can. But the other thing is, the solar edge system is super safe, and we can monitor every single panel so that we know if there are any issues further down the line. This is the solar skirt bird protection that we use, and it not only protects the array from pigeons getting underneath and making their nests, which is more common than you might think, but it also makes the array look neat and like it's really designed to fit on the roof, because aesthetics are quite important for a lot of people and they don't necessarily want a load of ugly solar panels on their roof. But in this case, with the all black panels and the solar skirt, it looks really, really smart. So let me talk you through what we've got here. We've got a 5 kilowatt solar edge inverter with 14 440 watt JA solar bifacial all black panels. We've got this single Tesla Powerwall 2 right now, but we are coming back in a couple of weeks to fit a second Powerwall 2, which will be stacked on top, and the Tesla Wall Connector EV charger. We've got our AC isolator here for our Tesla Powerwall, a Ubiquiti Wi-Fi access point, so the customer has got really strong Wi-Fi here for his vehicle and all of the devices, although we have done hardwired Ethernet connections to everything. So this network switch provides our LAN in from our router in the house, our hardwired Ethernet for our solar inverter, and our hardwired Ethernet for our access point, and this works on power over Ethernet. Then we've got our consumer unit here, which has the main switch, the breaker for the Tesla charger, the solar, Powerwall 1, Powerwall 2, garage sockets and garage lights. This is our document pack where we keep all the documents, and the MCS pack that comes through to the customer at the end of the job will go there. And then we've got DC surge protection device here, so that if there are any kind of lightning strikes or anything like that, any surges on the DC side, that will protect the inverter, and that's really important. That's our AC isolator for our inverter, and the generation meter, which logs how much power the system has generated over its lifetime, and a little whisker box here for our CT connections for the RS485 for that and various other CTs. So that's a little overview. Let me know what you think in the comments below. So is it worth upgrading an old solar panel system to a brand new one? Well, in this case, the answer is a resounding yes. Previously, our customer was generating about a kilowatt. Now he's generating over 3 kilowatts, and he's got battery storage to be able to store some of that excess solar and use it to run his house overnight, plus energy security with backup protection in the event of power cuts. But the question is this kind of setup right for you? Well, if you want to find out, there'll be a link below where you can get a quote from us, and we'll do a bespoke system design for you. But either way, thanks for watching, and we'll see you on the next one.